Hello people, welcome to another episode of the video series where we learn Kotlin following Codecademy's Learn Kotlin interactive course. In the last episode, we went through functions and now we will get started by learning classes. This is one of the hardest topics of programming. Why I say that? Because actually, after you learn the basics or the fundamentals of programming, you usually in universities or colleges, you move to another course, and that is object-oriented programming. So object-oriented programming, like working with classes, objects, interfaces, and as Codecademy puts here, encapsulation, polymorphism, inheritance, these are really advanced topics, and usually there are separate courses for that. But we want to do a simple introduction to classes at least, so that you can have an understanding, a basic understanding of what classes are and what is object-oriented programming, so that you can go to a separate course on object-oriented programming and learn more on the topic. Okay, so let's read along and see what awaits us. Introduction to classes. Kotlin, much like Java, is an object-oriented programming language. The term object-oriented refers to a language that is made up of objects and can utilize various methodologies such as encapsulation, polymorphism, and inheritance. These are, as I said, like some advanced topics. You can read if you wish. You can take a look. In this lesson, we'll make a brief introduction into the world of objects with a tool known as classes. Classes allow us to create blueprints of everyday objects and then utilize this blueprint to create as many unique instances of it as we'd like. Assume we're building a program for a car dealership. We would need to store some of the following basic characteristics for each car: model, year, and color. We can use a class to create a blueprint with all of these properties, from which we would then create each individual car. Each unique car would be an instance of this class, also known as an object. Instance and object, okay? These can be used interchangeably. With each new concept we have learned about in this course, we've made our programs more dynamic and customizable, and classes will be no different. With classes, we'll have the ability to mimic real-world objects in our code and tailor them to our liking. In this lesson, we will focus on creating classes, generating individual objects from them, and exploring their available functionalities. Okay, cool. Take a look at the image to the right. Yes, this is, I think we're in the entrance of Dev City, and we're about to enter Dev City, meaning that we will be developers. We can call ourselves developers after finishing up this lesson. Cool. With all of your help and hard work thus far, Cody is finally en route to Dev City. Dev City utilizes blueprints classes to generate each one of its skyscrapers. Notice how although each blueprint is the same, the final result or object is different. Let's see. We have these blueprints. Actually, they are yellow. But yeah, with these yellow blueprints, they are called classes. We make some skyscrapers with some, for example, +2 levels and a triangle cap. Or here, -2 levels, like this, okay? So we could create objects which are instances of the same blueprint or same class, but they have different properties. Yeah, that is the whole idea of using classes. Let's go to the next exercise. Creating a class. Now let's practice writing our own classes. A Kotlin class is declared at the top of a Kotlin file outside the main function, like declaring other functions. When we want to declare a class, we again go outside of the main function. With a class keyword here or here, followed by its name, the class name, okay? You can put here skyscraper, for example, or car, or person, or student, or anything. The name of a class should always start with an uppercase letter and use the camel case form. Camel case is, if you remember, you start capitalizing each consequent word in a variable name, but this one is upper camel case, like it starts with an upper case letter and then keeps capitalizing it with each upcoming word. Whereas the variables start with a lowercase letter and then keep capitalizing it. So this is called upper camel case and the other is called lower camel case. Cool. The class body is contained within curly braces and will hold all of the properties and functions related to that class. So if you go back to our early videos, you can see that some of the properties and functions of the string class, do you remember those? Or you may remember that for properties we weren't using pair of parentheses, but the functions we were using them. So this is because string was a class. Okay, it is not defined by us. It's in the Kotlin standard library, but it's a class. So classes can have properties and functions related to that class, and you will put those in between these curly brackets or curly braces. Note, it is optional for a Kotlin class to contain a body. Thus, if the class has no body, we can omit its curly braces, resulting in the following declaration. Okay, let's revisit our real-world car example. Suppose we create the following class car. Our blueprint is complete, but it's not of much use to us, empty. Any car possesses several properties, including the year it was made, its model name, and color. Let's add these. So it's no different than defining variables, okay? If you put a variable inside the class body, directly inside the class body, you create properties, and these properties belong to this car class. So each instance you make out of this blueprint, this class blueprint, they will all have all of these properties. Okay, so year, model, and color, we created those and initialized those. Now, anytime we create a car object from this class, it will possess the properties year, model, and color and hold their respective values. In the next exercise, we'll learn how to create objects from a class. For now, let's practice with the Kotlin class syntax. In book KT, declare an empty class called book. Since it's empty, I think I can omit the pair of braces, but let's see if Codecademy accepts it. Yes. And now, add the following properties and the values they hold. Pages with value 320, title with value Harry Potter and the Sorcerer's Stone, and author with the value J.K. Rowling. So now I need to create the body of it because I want to add some properties. First property is called pages. I can use val, I can use var. Okay? Usually if you want to change it later, you can make it a var. So var pages is 320. Var title is this string and author is J.K. Rowling. Cool. This is how you can create a class and create properties inside. We will see how and why we do that and what is its use to us later on. So, creating an instance. Now that we've created our first class, let's create an instance of it. An instance of a class resembles an object that is a member of that given class. Recall the car class from the previous exercise. Cool. Yes, this one. To make an instance of this class, we'd utilize the following syntax. Well, car or my car equals car, a pair of empty parentheses. So this is not a function. You saw that you need to put a pair of parentheses after a function name, but this time you're not putting a pair of parentheses after a function name, but you're using the class name here and a pair of parentheses to instantiate or to create an instance of this class car, okay? And here you just create a variable to store the created instance, okay? We've declared the name of our instance to be my car. This name is arbitrary and it is up to developers choosing. Following the assignment operator, we've invoked the car class within the name of the class followed by parentheses. Yes, with this line of code, the my car instance now possesses all the properties and their respective values that were specified within the class body. Yeah, this is super cool. Now that we have a car, that means we have 3 properties inside. So if you want to reach to this year of this car, you can use mycar.year, mycar.model, and mycar.color are to reach the other 2 properties. So you can use the dot syntax to reach any property inside an instance. We were doing that for lists and for strings, if you remember. Voila! You created your first object. Think about what you have learned about classes and their properties. What is one way that might need to improve upon with this code? Follow the checkpoints below to find out. Okay. Within the main function of building KT, create an instance of the building class. To create an instance or to instantiate, you can use var or val. Now I will pick val, and then you put a name to your variable. For example, this building should be called residential building, and you need to type the class name, building, and a pair of parentheses. Now you create an instance and store the instance in this variable. Let's run and see if it passed this one. Cool. Now create 3 print statements that use dot notation to output each value of the instance residential building. Okay. Println residential building dot year built. And let me copy and paste those to replace year built with height and type. Cool. Let's run this and see all of these values can be accessed. And optional, if you create another instance of the building class, say commercial building, and output its property values, what do you expect to see? Yeah, that is the problem actually. If I create another building called commercial building and print those values for commercial building, we will see the same values, okay? And this is not useful for us. We want classes to create different instances holding different values for the same properties, okay? So let's check out the hint. With each and every instance created for the building class, the values will always be 2016, 400, and limestone. This may work for some programs, but not for the most, where we'd most likely need to have custom values set for each instance. Yes. There is a very small chance that one residential building has the same exact characteristics as another commercial building. In the next exercise, we will explore how to customize these values. Finally, yes, cool. Primary constructor. Looking to customize your instances, you come to the right place. Kotlin classes provide us with something called a primary constructor that allows us to declare properties and initialize them when we instantiate an object. Now, let's see the shorthand syntax. This is a shorthand syntax. Now, after creating the name, we create a pair of parentheses and put some kind of arguments inside, okay? Let's read along. We've now introduced a pair of parentheses in the class header that define properties X and Y. Previously, we would have had something like this, yes. Each property would already have its default value set, but with primary constructors, we give our program the ability to set the values when an instance is created. Refactoring our car example from the previous exercise to utilize a primary constructor in the header, we get the following line of code. So here we moved our properties for a car into the primary constructor, into the header. Let me adjust this a little bit. Here you can see that now they are in here as kind of arguments, okay? Because this is actually a primary constructor is actually a function inside. This is an insider information, but yeah, let's not think of it now. And if we want to instantiate a car, now we can give some values when we are creating it. So when we're creating this my car object, we give 2011 Jeep and blue, but when we're creating the friend's car, now we give 2015 Mazda and red, okay? So you can customize the values inside if you follow this strategy. Now we've successfully created unique instances of our car class and customized their values. Now my car's year is different than my friend's car's year. Cool. In person KT, add a class person that contains a primary constructor. That means I need to put a pair of parentheses and with the following properties: name, age, and favorite color. Name should be a string. Age should be an integer. Don't forget to put age integer, and favorite color, again a string. Okay. Now after passing that, within the main function, I need to create an instance of the person class called me. So me is equal to a person, and set the values for each property that resemble your characteristics. So my name is Safa, and my age is 26, and my favorite color is red. Cool. On the following line, create another instance for my friend, and again, let me adjust this. My friend is also a person, and let's say this is an imaginary friend, not because of I don't have any friends. Yeah, so let's say I have a friend called David, which is 32 years old, and favorite color is orange. Cool. Let's run. Cool, we passed this one as well. Now, use a string template along with a println statement for each object and output the following text. For each object. Make sure to replace underscore with the appropriate pronoun, my, her, his, or their, to match the instance. Check the hint for guidance. Okay. How can we do that? Let's start by writing a println statement and a string template starting from name. So me, but I need braces as well. Me name is, where's the dollar sign? Me dot, oh come on, me dot age, years old, and let me do that, and his favorite color is me favorite color, me dot favorite color. And I need to do the same for my friend, so I'm gonna replace each one of the me's into my friend so that it'll print 2 lines of strings. Safa is 26 years old and his favorite color is red. David is 32 years old and his favorite color is orange. Cool. Let's go to the next exercise. The init block, the primary constructor, does not contain any code other than the properties and their specified data types. What if we would like to calculate a person's age using the year they were born? We can do this with an init block. Init is short for initializer and allows us to add more logic to our classes. Suppose that we have the following class mascot, and mascot has a name and a platform, which is an integer, and a year created, which is a string. We would like to use the year the mascot was created to calculate its age. We can do so by adding this logic within an init block. So we get the year created from outside of this class, but we calculate the age here in the init block using an arithmetic operation. Okay, so we created a variable age within the class that we will use to store the value of the calculation 2020 minus year created. And then in the initialization, like in the init block, we can also print something which will be printed whenever a new mascot is created. So if you do that, create a new mascot named Cody. By the way, there is something wrong here in this example. Platform should be string, not an integer. Okay, they corrected it in here, but they forgot to change it here. So assume it's a string because Cody is a mascot of the platform Codecademy. It goes like this. Cool. In employee KT, we created a class. Let me again play with this. In employee KT, we've created a class that accepts several properties in its primary constructor, first name, last name, and years worked. On the first line within the class, here, declare a variable, okay, full name, okay, and in it, store the combination of first name and last name with a space in between. Okay, you can use string concatenation or string templates. I use string concatenation here to add up strings. Is that all? Because I didn't use the init block, but it doesn't say me so. Okay. Yeah, we passed it. Below, create an init block now. Cool, now we can create an init block and set up the following logic. If the years worked is greater than 1, if the years worked greater than 1, then I need to output a text. Full name is eligible for a raise. Whoa, congrats. Else, I keep forgetting that space. Old habits. Full name is not eligible for a raise. Okay, I'm gonna copy the whole thing. Is not eligible for a raise and no exclamation mark just yet. Make sure you make sure to use the variable you created in the previous step and string templates. I did both of them. Yes, we passed this. And now in the main function, create an instance project manager. And it should be an employee, which is our class's name here, okay? And first name should be Maria. And last name is Gonzalez. Okay. Years worked is 2. This one is an integer. Yep. Now, whenever I create this, you can see that the init block works, and what is inside init block is executed, and we see Maria Gonzalez is eligible for a raise text in the console. But there is a problem, I guess. No, this is not a problem, but there is a problem here. Did you add the values Maria Gonzalez and 2 to the instance declaration? I did. No, I didn't. Okay, I had a typo. That's why I get a cross here. Now I had a check mark and can go to the last exercise, which is member functions. I said previously that you can put properties and functions into a class. Now let's see how to put a function into a class. When you put a function into a class, by the way, they are called member functions. So let's read member functions here. Now let's explore how to add even more functionality to our classes with functions. A function declared within a Kotlin class is known as a member function. Member function possess the same qualities and abilities as the user-defined functions you've learned about in the previous lesson. The syntax is the same as well. Some things to keep in mind: when an instance of a class is created, the object has access to any and all functions that exist within the class body. Okay, Unlike the code within the init block, which executes automatically, the code within the functions will only execute when the function is called. For example, in a cat class, if you have a member function speak, which will print meow, okay, it was a nice meow, by the way. We created, what was I saying? Yeah. So if you create a member function like that, you need to call that member function, like myCat.speak, or inside any other member function to get this code executed. Okay, we created a simple class cat with a primary constructor and a single member function. We can now create an instance of the class as so and call the speak function. Yes. I don't remember Garfield to be meowing. He always spoke, no? Yeah, so speak is a good selection of word there. Inspect the class dog on the right. Okay, we have a class dog here. Whoa, a big class. In the primary constructor, we have name, breed, and competitions participated, a list of string. Okay, and whenever you create a dog, it prints all of the competitions in the competitions participated list using a for loop and printing the name participated in competition for each line. Okay, I inspected it. Now they say add a member function called speak that outputs the following text. Name says woof. Okay, to create a function, you just go ahead and start it by fun and type the function name, which is speak, and a pair of parentheses and a pair of curly brackets, and here I need to print, if I will, println name. I can reach to this name here. See? This is the cool thing about member function. I don't need to get any name in here, but since I'm inside of this class, can you spot that? We are inside of this class. The start starts here, the class starts here, and ends here. So this function is inside of this class, so it can reach out the properties of this class. This is very cool. Name says woof. Let's run this. It doesn't get printed because we haven't called speak function yet, but we will right now. Create a dog instance called Maxi. Maxi is a dog, which is a name Maxi, and her breed is poodle, and list of competitions. So how to create a list of strings? Do you remember? We were using list of, okay, to create a list. So it should be Westminster something and AKC something here. So a list of 2 strings. Okay, so this is the third parameter, third argument. If you see here, this is the third one, and the type of this argument is list of string, so we need to provide a list of string here. See? Cool. Run your code. Okay, I ran the code, but still we didn't see woof, but we saw the part where name participated comp sections. So Maxi participated in Westminster Kennel Club Dog Show, Maxi participated in AKC National Championship, and since this is init block, it automatically gets executed. But for the speak function to get executed, we need to explicitly call it. So let's see, Maxi speak. Okay, you can read functions like this. Maxi, hey Maxi, speak, and then it'll speak. Maxi says, woof, nice. Let's do a review. In this lecture, we learned the following concepts. A class is an object-oriented concept which resembles a blueprint for individual objects. A class can contain properties and functions and is defined using the class keyword followed by a name and an optional body. An instance is a member of a class created by calling the class name followed by a pair of parentheses and any necessary arguments. We can use the dot syntax to access the value of each class property, like car.year_built, okay, or book.author, kind of this. A class can have properties with default values or ones that are customizable with the help of primary constructors. A primary constructor allows us to set each property value when we instantiate an object. The init block gets invoked with every instance creation and is used to add logic to the class. A function, finally, declared within a Kotlin class is known as a member function of that class, and in order to invoke a member function, we must call the function on an instance of a class. So if you want to, let's say, use this is a member function, you need to use the instance you created and you use dot syntax to call this, like you do for reaching properties like this name. Okay, cool. We have some code here and we won lots of achievements, badges and such. Let's see the exercise. You did it, yay! You completed the last lesson in the Learn Kotlin course. You should be immensely proud of yourself and your accomplishment. Thank you, Codecademy. I'm flattered. This was no easy feat, but you made it to the dev city and can proudly say you're on track to becoming a master of Kotlin language. See, you're on track. Still not there. We've not seen half of Kotlin actually, and we have a lot to learn in fundamentals of programming, and still there's object-oriented paradigm, which is a complete topic on its own, and you can take lots of courses and classes on object-oriented paradigm itself. But don't worry, if you could reach to this point, completing all the exercises, following me doing that, you will have a good ground on programming, okay? So that now you can do lots of exercises to be better programmer and then learn more topics. Maybe you can jump to Android development, or maybe you want to build backend side, server side programs, then you can move to Ktor, for example. But firstly, I suggest you get better in programming by solving lots of problems. You can go to HackerRank, for example, and try to go with the algorithms there. I'm also planning to make some videos on those. Also, you can follow me on Telegram. I'm posting some. Let me give you the Telegram address. It's t.me/Android with Safa with the underscores. Okay, so if you go to this Telegram channel, I'm constantly posting educational material to learn Kotlin and also to learn Android development. So if you want to pursue a career in Android, I strongly recommend that you get into this channel and Follow me posting Kotlin challenges, follow me posting articles on Android development and software engineering in general. Okay, let's finish up here. Run the code on the right and enter the following 2 commands for a special message from Cody. Okay, let's do that. Copy, paste, enter. And the second one, Java jar. Please enter your name. Okay, my name is Safa. Dear Safa. Yeah, let's do this. Dear Safa, thank you for embarking on this journey with me. I couldn't have gotten through the treacherous waters of Conditional Creek or hiked up the looping mountains without your help. You now have the fundamental knowledge to go on and continue your Kotlin journey in the world of Android application, web development, or more. The world is yours. Good luck. With love, Cody and the Codecademy team. Thank you, Codecademy team. It was a pleasure for me. I think I finished this journey multiple times with my students. And now I finished another one live on YouTube on air. Thank you for creating this kind of quality materials and providing these for free. Yeah, some part is free. Like you also sell Pro, which I recommend people to buy to see the extra material, the quizzes and the projects, and do lots of exercises on what you learned. But still, a big portion of the course is provided for free. This is a big thing, okay? This is not a small deal. This is a big deal. So, yeah, I need to do a shout out for Codecademy team. Yeah, an applause. Okay. Thank you for watching this series, the video series where we learn Kotlin ended here, but I will keep creating video content on my YouTube channel. So if you haven't already, please subscribe. And if you have any questions, please send them as comments below the videos on YouTube. Cool. It was a pleasure to learning with you, and see you in the next video.